right. Welcome to Science Club number 7. Today, Ravi and I are going to talk about recommender systems. Excuse me. This is the Jupyter notebook that we're going to look at is a rather long notebook. It has several parts to it, so we're going to kind of focus mostly today on the first part of the notebook, which has to do with data cleaning and preparation, which, as we've talked about before, because a lot of the codes that we're building now are so simple to actually do the machine learning piece or the data science piece, probably 80 to 90% of actual data science work in the real world has to do with data cleaning and data prep. So we're going to go over that part. And then next week we'll go over building the actual recommender system with the rest of the notebook.
And recommender systems, for people who don't know, is basically recommending things based on your past history of how you have rated things and stuff. So basically, when Netflix recommends you the next movie that you might like to watch, based on all the interests, based on all the ratings that you have provided, what all shows you have watched, that's a recommender system. And similarly with Amazon, it provides you with the next products that you might want to buy. And so that's basically what we are going to try to do over here.
Yeah, I think we've all experienced that if you're interacting with things like Amazon or Netflix, that you get those recommendations. I'll get pretty weird recommendations sometimes because I'll sell some of my wife's things on eBay or whatever, and then I'll get advertisements for dresses that I'm not interested in. But that's the way these things work. So we'll see how this goes.
That tells us that there is a lot of scope still in the recommender system field.
Yes, yeah. There's a lot of there's still a lot of jobs available for fine tuning those things. To deal with noise added by other processes. So the notebook that we're getting actually, we're pulling from this Medium article called "Building a Recommender System with Pandas." So this is kind of fun because this only uses the Pandas library. So we're not using scikit-learn. We're not using TensorFlow or PyTorch. We'll just be using Pandas to do the data cleaning and then building the recommender system.
And if you remember from one of our past sessions, Pandas is a Python library that helps you in manipulating data and exploring data, and right now we see it also helps you in building a recommender system.
Let's see. So I have brought up the GitHub. If you go down to the bottom of the article, he's got the link. Lawrence, that sounds like a he, has the link to his GitHub page. And so that's here. And so there's a nice Jupyter notebook that he built. I believe this is the final project in an IBM machine learning course. So we may, learn more about that later as Ravi and I dig into, finding resources for the Data Science Club. But in order for us to use this, we need to get it into our Jihad environment. So I'm going to come here to the main repository. And so this is what I was talking about. He's got several other notebooks. And we're just going to clone the entire repository. So first things first, we need to set up a job in the job composer to do the git clone. Since this isn't our repository, we don't have the nice README that has the job composer job. So I'm going to come in here to one of the previous sessions. We did this building autoencoders in Keras. And so we can actually just copy this job and switch out some stuff. And that should get us what we need. So we'll come here, we'll go to jobs, job composer, and I'm going to do a new job from a default template. And then I'm going to come down, I'm going to open the editor, and I'm going to paste this in here. I'm personally using most of my compute right now on the cluster, so I need to actually edit this to use Pascal nodes. As batch, is it dash dash partition?
Yeah.
Equals Pascal nodes.
And for people watching the video, you don't have to actually enter this.
You don't have to add the Pascal nodes. This is these are the nodes that have the GPUs on them, and they have different priorities than the CPU nodes. I think right now I'm using something like 230 CPUs, and so I'm at my limit on that side. So I got to use a GPU node here, but you're perfectly fine to just leave it the way that it is. We're gonna come in here. We're gonna change the folder from building autoencoders in Keras to, we'll just call this recommender systems, and then we got to come to his repository, and we'll click this clone, and then we'll copy that to the clipboard. I come back to the editor. And then here we go. Okay. So his repository has a very general name, machine learning, and we're gonna put it in a folder called recommender systems, because that's what we're interested in. All right, so we're gonna save, and then we can come back to the job composer, and we can see, okay, that should work. Did I miss anything, Ravi?
No, it looks good.
Okay. All right, so now we're gonna submit this job. And it's queued, it's running, and it's completed. So that was really fast. So I don't think it's a very large repository. So we'll just check the Slurm log. Yeah, it looks like nothing went wrong over there. And so now we can come over here and we can just start up a Jupyter notebook. I want to make sure, yeah, so I got module load Anaconda and CUDA. I don't think Pandas is optimized to use the GPU,
Yeah.
so it shouldn't matter for this time around, but we'll see. Again, with a lot of the machine learning stuff, we use the Pascal nodes. For this example, you don't have to, but that's what I tend to use.
And Pascal nodes basically just mean that you are going on one of the nodes which has the GPUs available.
Yep. And you could certainly download this or clone this Git repo to your local laptop and run it on your local Jupyter notebooks through Anaconda if you have that set up as well.
Yeah, just keep in mind that since we are using Pandas, that Pandas library needs to be in your Conda environment.
Yeah. Okay. This was a previous session. I can delete that one. All right. So now I'm going to connect to Jupyter, and let's see. We're going to go to RCDSC, recommender systems, and just like magic, all of these things are already in here. So which repository was it that we were in? Building a content-based recommendation systems. Okay. You see he's got several other recommender systems items in here, but we're going to do this building a content-based one, and we'll just see how far we can get. All right. So first things first, we're going to import pandas. Now this is a fancy Python thing that we haven't talked about before. Whenever you import a library, you can kind of rename it for your purposes. So instead of having to type out pandas every time, you can just type PD. And let's see, what kernel am I using? I think I'm just on the Python kernel.
Yeah.
Apparently the base Python environment in
Okay.
Anaconda has pandas already installed.
It should be good enough, I believe.
Yeah, so we'll see if anything crashes on us, but it should work. If we did not have pandas in the environment, it would have thrown an error here. All right, so we're gonna import pandas, and then now this one, so it's setting the max rows to 20, so that's just helping prevent overwhelm while we're printing stuff out to look at it.
Yeah, it's basically so that you can do some basic exploration of the data, but don't get completely inundated with them. So
Yeah. All right, so now here's a moment of truth. Let's see if these things are. Oh, okay, this is just the file names. We haven't actually downloaded anything. All right, so these are theoretically where these data are. We can just double check real quick. Hey, there's actually stuff there. Okay, so that's good news.
And Python should be able to automatically download them from these locations, and we'll do it a little down in the.
Yeah. So the good news is that those things are actually there. And yeah, like Ravi said, when we get to this read CSV, you notice that it doesn't have to specify that it's a web location. Python just needs to know what the location is, and there actually has to be a file that you can access there. So the other thing that is going on here is that in databases, people use lots of different conventions for rows where there might not be a value. So maybe a film was produced, but maybe it didn't get rated on IMDb or Rotten Tomatoes or something, so it doesn't have that value. Or maybe it was an independent film, so it doesn't have a genre, something like that. So this is just helping take care of that.
Yeah, and it also depends upon a lot of individual data gatherers about how they put those values. So they can just leave it blank, they can put none. Some people do NA but not available, and so these are the various options that could be there.
Yep. Yeah, and so by specifying NA values equals the missing values, then Pandas will interpret all of these things as the appropriate not a number or not available value according to Pandas. All right, so now let's explore our movies data frame. So we have almost 10,000 movies, and we have 3 columns for this data frame. So this is movie ID, so that's just an ID number. We've got the title, which appears to include the year in there, and then the genres associated with it. Apparently Toy Story is a genre hog. It's kind of got everything in there. So let's go and look at, now we're going to look at the ratings. So, all right, so these movie IDs should correspond with these movie IDs, right?
Yeah. So they both are related in just by their movie ID attribute, and yeah. So whatever is the rating that you see over here, like the first movie gets 4 ratings, and if you take a and if you go over there on the movies table, and whatever is the first, it's Toy Story, right?
Yeah.
Toy Story. Toy Story gets 4.
Yeah, so they rated. So this one has 4 columns. We've got user ID, movie ID, rating, and timestamp. So we're building a recommender system. So the user ID corresponds to an individual person. And then like Ravi said, the rating is what that individual person rated that movie. So this person gave Toy Story, Grumpier Old Men, and Heat all a 4. So, okay, that makes sense. Took me a little bit for my brain to wrap around that. All right. Now we're going to look at the movie's data frame and start doing some data cleaning there. So here, we're going to remove the year and make it its own column. So, this is valid data that would be nice to be able to use for our recommender system. And so this line here is extracting from the movie titles. It's doing the string parsing to remove
it's basically what
the
it's
year.
It has given a regular expression that this thing is the regular expression that's going to try to identify a number. And
okay.
so there you have one of them is the first bracket that's opening, and then you have digits.
Yeah, so it's looking for a 4-digit number that's between 2 parentheses.
Yeah.
Okay.
And that's how, if you'll see, that's how it has been named, because we are just giving the year, not the actual release date or anything. So it makes our work easier.
Yeah. All right. So then we can come here, and then we're further processing the year by removing those parentheses so that it's just a number. And then here, we're removing the year from the title. So you see here, we still have the year. The year over here doesn't have parentheses anymore, but now once we've done that one, now the year is gone from the title. And so now we're going to strip any ending whitespace characters. So again, this is kind of the definition of data cleaning. White spaces are things that don't really add to our analysis, and specifically these white spaces that are at the end. So since we've stripped the year, there may be a space here at the end of the movie titles that needs to be taken off. So this is just guaranteeing that we've indeed taken that off. And so let's see. All right, so now we want to make our movie genre readable by Pandas. And so this setup of adventure pipe, animation pipe, children pipe, comedy pipe, fantasy. So this is a list of genres associated with Toy Story, but Python doesn't recognize this format. And so right here, we're updating that to match kind of the Python convention.
Plus, if you want to learn anything from this data set, since that entire group, adventure / animation / is going to be considered as a single value, it doesn't really add to building a recommender system, because you want it to be an adventure to be a separate thing and animation to be a separate thing.
Yeah, by having these pipe characters, Python's just going to read this as one block of text. But if we split it up like this, like Ravi said, now we can programmatically say that it's adventure and animation. And so then we can relate Jumanji to Toy Story, whereas previously adventure children fantasy is a different genre than adventure animation children comedy fantasy. But now we can see that Jumanji has a subset of the genres that Toy Story has. Okay. All right, so now let's look at our data frame a little bit more. All right. So we're looking at the memory consumption and if titles are arranged logically. Okay. And then, all right, so this is the memory consumption. So this tells us, by doing the .info, this tells us what data types we've got going on. We do expect that the movie ID is a number. It's saying that titles is an object, genres is an object, and year is an object. We'll have to see. We may end up having to go back and change year to a number, but I don't know. We'll see what we have to do.
Yeah, and I mean they are really going into data cleaning. I wasn't expecting to see
Yeah,
how
this is
you are
pretty-
using memory.
Yeah, this is pretty hardcore, which is good. All right, so now we're looking at memory, and then now, yeah, so we're gonna convert movie ID from int64 to int8 to save memory space, and it looks like actually we're converting it to int32. So that comment doesn't really follow, but if we do this and then we come back, let's put this in here. Yeah, so after we convert the integer to a smaller integer type, then movie ID takes up less memory. In this particular example, we're dealing with a spreadsheet that only has 10,000 lines on the movie ID side, so that's not a huge deal. But you can imagine that if you're at the scale of IMDb or Netflix and you have millions of users,
You have to go with the maximum available.
Yeah, that's a pretty big deal. So that makes sense that we're doing that. All right, so now we're going to check. So this function here, .isNA, checks to see whether or not a column has a value in it or not.
Yeah, so if you remember, at the beginning of this notebook, we mentioned some of the characters that should be interpreted as NA when we were actually reading in data. And yeah, so this is going to define wherever it found those characters.
Yep. So the good news is the data that we originally pulled, the movie ID, titles, and genres, doesn't have any missing, but our calculated field, the year, has some missing values. So now what we're going to do here is we're going to just numerically say that 0 is a number that we're going to use to replace the missing values, so that then when we write our algorithm later, if we see a 0, we know not to take the year into account. All right, so that's what this fill NA, so it's going to fill all those places where there was not a number with 0. All right, now we're going to convert the year into a number. So again, he's got this comment that he's converting from 16 to int8. We probably certainly could, but we're just going to follow what he's doing here, which is just converting it to a number, because as we saw earlier, it was an object. All right, so now if we look at, okay, I've fiddled with the calculations. Hang on a second. I think I've already messed it up, haven't I? Yeah, that's all right. Yeah, so what we saw earlier was that the movie ID was taking up 77,000. Is this bytes?
Yeah, I think so.
Yeah, I think that's bytes. and the year was also taking up 77,000 bytes. And now that we've done these data conversions, our year is only taking up 19,000, and our movie ID is taking up 40,000. So that's a pretty big space savings, again, especially if we're talking about doing this on a big data scale. And now if we look at our types, we can see that we've got int32, object, and then int16. All right, and now if we look at the header of our movies data frame, we see our nice split up of title, genre, and year with our formatted genre and year. All right, so now the next thing is to one-hot encode the list of genres. So do you have a good summary for what one-hot encoding is?
So one hot encoding basically means that in this section, so in genres, you'll see that there are different genres available, like adventure, animation, children, comedy, fantasy, and then there's romance. And one hot encoding basically means that in the first row for Toy Story, you are going to put 1 as a value for all adventure, animation, children, comedy, and fantasy. But for the romance genre, you'll put it in a value of 0, that it's not included in that romance genre.
Yeah, so basically we're turning our list of genres into columns of genres, and then basically, as Ravi said, assigning that column a 1 if that movie is considered in that genre. So yeah, that makes sense.
Yeah, this is basically again for your recommender system in the end, where it will know to look for, it can make sense of the value 1 rather than just the word adventure.
Yeah.
It will be easy for it to be like, okay, I have a numerical value, over here it's 1, and yeah.
Yeah, the computer doesn't know what the word adventure means, but it can use the value of 1 or 0 to specify, is it a part of this group or not, which is all it's doing. All right, so yeah, so we're gonna one hot encode. So now we're gonna look. All right, so we're gonna say we're gonna first copy our movies data frame into the movies with genres, and then now we're gonna iterate through, and we're going to add a column for every genre, and then we're gonna specify a 1 if the movie's inside of that genre. Does this deep copy make those genres based on that list?
No, I'm not really sure. I think deep might be, since right now our genres are a list.
Let's just do an experiment here to see where that's happening, because I'm trying to read this code and I'm not seeing where the for genre and row genres. Okay, so let's do that. Oh, let's put this. Yeah, okay, so I'm not sure what the deep flag does. We'll have to read up on that.
My best guess would be, since we have a list in our data set, the genres section, deep might be doing that, but I'll try to take a look at that.
Okay. So I think the new columns are getting created here implicitly, right?
Yeah.
In this movies with genres .at index genre. So the new column is getting created there implicitly. So if we do that, then you can see, okay, we've got we've got ones anywhere that Toy Story was indeed in that genre, and then nans or not a numbers anywhere else. So this is any other film genre that showed up. And then we're going to go ahead and fill our not a number values with 0 to finish out the one hot encoding. So we have ones for yes, this movie is a part of this genre, and then zeros for no, this movie is not a part of this genre. I didn't realize Grumpier Old Men was a romance. All right. I have to go back and rewatch that one and figure that out. All right, so now we're going to start doing the whole thing over again, but with our ratings data frame. So first, let's look at our ratings data frame. We've got user ID, movie ID, rating, and timestamp. We don't need the timestamp. I could perceive that you might eventually do a recommender system that updates based on like the last month, gives the last month more weight. For instance. So if you rated things highly in the last month, maybe it gives you more horror films because you've watched more horror films in October, and so it or during Halloween or something. So maybe it adds more weight to that. And then once November comes and you start watching holiday Christmas movies because Christmas is coming up, then it switches from horror to Christmas a lot faster. I don't know.
That's a very good point. I mean, most of the commercial recommender system, I think they would keep a track of when was the point when you started liking a particular kind of movies. Because if they are just going by my entire lifetimes of recommendations, I might not like the type of movies that I liked 10 or 15 years back.
So it'll be interesting to see how the rest of this plays out. But for the purposes of this example, we don't need the timestamp to build it. And your recommendations as you rate more movies or watch more movies, what have you, that will also kind of get taken care of automatically anyway, because the law of averages will kind of wash some of that stuff out as you stop watching it. All right, so we've dropped. So this dot drop we're deleting a column and not a row, I think is what's going on there. All right, again, we're going to do this thing with the data frame types. We're going to see how many missing values are there. And, he didn't do the memory thing. Let's do the memory thing because we're at the end. We're at where we're going to start building the recommender system, which is what we're going to do next time. So let's just finish out this data cleaning portion by, we're going to go the extra mile here and come back up. And we're going to look at the memory usage. So let's copy this down in here. Let's see, let's make a new cell. All right. So let's see, this should be ratings. Ratings, data frame, ratings.
We got 2 DF and
I got 2 DF. Okay, thank you. All right. So this is actually a lot bigger of a spreadsheet. So it's interesting that he didn't do the
because I can make the case. At least the user ID we should be able, but it also depends upon how many users are there.
Yeah, I mean, all of these are int 64. Certainly the rating could be int 8, I think, right?
Well, they do want it to be in decimal points, so you should be
Oh,
able to get
okay.
4.2, 4.3.
I
believe.
gotcha.
But I mean, just exploring the head of the data set, it doesn't look like they have any fraction in the data set.
Yeah, it doesn't look like it. I know maybe you have, okay, here's 4.9.
Oh, they have.
Okay, so this person, apparently you can rate things on a really fine scale, which is surprising. I would think that from this, let's look at the top 20 ratings here and see. Oh, timestamp not found in the axis. Oh, it's because that part.
Yeah,
We've already dropped that. Okay, so this is what I actually suspect is going on. I think
Yeah, it's just taking the average after that.
because when I rate things, the star scale doesn't allow me to do
Yeah.
points. So yeah, so let's come down in here and we're gonna change the rating data frame dot, let's see, so we want to do the movie ID to int 64 or int 32 because there might be a lot of movies.
Or we should be able to do float 32.
For the movie ID?
Oh, sorry, it's the movie
Yeah,
ID.
we're gonna do the movie ID.
32.
We're gonna do all of them, but we'll do ratings data frame. Okay. So we'll do movie ID. We'll do
User ID.
User ID. And then let's also do rating. All right, and I personally don't think that we need to have our rating be a float object at this point, but because we might be manipulating it as a float later,
Yeah.
it might still be nice to leave it in that, so we can at least go float 32. And then once we do that, let's look at our memory usage again. All right, so yeah, so as expected, changing these from 64-bit to 32-bit numbers halved the amount of memory that we were using for our data frame, which, as you can see, going from 10,000 rows of the movies to 100,000 rows of the user ratings really jumped up the data size quite a bit.
Yeah.
And so again, I like that he did the memory thing, because that does point to, like, if we're doing this in a big data setting, this data type is going to really impact stuff a lot.
It also underlines what William was mentioning at the beginning of this session, that data manipulation, data cleaning, and preparing data for machine learning is one of the more time consuming and one of the critical things that a lot of data scientists do in their day-to-day work. And generally, whenever we show you what kind of data cleaning that we do, we tend to not go this deep into how you clean your data, about how you manage the memory of your data. But yeah, these are the ways you can see how you can manipulate your data and get it ready for your machine learning models.
Yep. So next week we will dig into the second half of this notebook. You can see the little scroll bar over here. We're about halfway through. So we'll dig into the rest of this, of actually building the content-based recommender system. but you can feel free to go through the rest of this notebook yourself, and just feel free to ask Ravi and me questions in the comments, or send us an email, or come to the Research Computing office hours. And if you're enjoying these and you'd like to get more of these videos and participate in the Data Science Club, like the video and subscribe to the channel, or just send us an email and we'll get you on the user list for Jiha, and we'll make sure that you get these things as we put them up. So, all right, well, thanks for tuning in.
Thanks.